to another statistical topic. And this time around, we want to focus on what I call repeated measures. Now, the outline today, like today's topic, just going to be an introduction. Now, in today's, you're going to learn basic concepts of repeated measure. We're also going to talk about longitudinal and cross-sectional analysis. And of course, there's going to be our example. Now, I'm going to start with what is a repeated measure. Let me just first tell you this. So the type of data that we use in repeated measure is a longitudinal data. But before I go into this title, I think I would like to have a recap on what we've done before so that we'll be able to retrace our step, okay, back to this topic. There is nothing that we cannot undertake with statistical approach. I'm going to say that again. Whenever there's a problem in a stochastic environment, don't forget I told you the other time, we live in a probability space because there's a lot of variations around. And because of that, we normally want to compare things. And if there's no variations, there's no way we're going to be thinking of comparing. Okay? So now that we want to compare things, I remember when I started this course, I was reviewing conventional statistics like one sample t-test, two sample t-test, all the way to analysis of variance to ANOVA. Now, let me tell you this. I can start, if I want to start my comparison, do you know my comparison can start from one group? How? What am I comparing in one group? Maybe somebody make a claim. Probably, maybe the person said the annual average income in the United States. Maybe the person says 40,000. And I'm going to say, okay, I want to investigate that because following every claim, we'll normally want to have an investigation. Now, what do I want to compare? I basically want to compare sample mean with the population mean in that regard because the claim of that person becomes an hypothesized value for me, which is a population mean. And when I investigate it, I'm basically going to get a sample, right? I get a sample mean. What am I testing? I basically want to test if there's equality or if there's no significant difference between the sample mean and the hypothesized value. That is a comparison in one group. When I go to two groups, this time around, if the two groups are independent, then I'm basically going to use a two sample t-test, provided if assumptions hold. Okay? And if the two groups are dependent, I'm going to say that again. If the two groups are dependent, then I'm basically going to use a paired t-test that we also call a dependent test. That is when two groups are dependent. Okay. Now, in a situation where I'm no longer comparing two groups, but I'm, want to compare more than two independent groups, the analysis of variance comes in. You can see this story. The analysis of variance comes in. You may be considering one factor experiment, it may be two factor experiment, it may be three factor experiment, it could be factorial experiment with interaction. Now, let me just tell you, all what we've done before now, we are assuming independent groups. I'm going to say that again. All what we've been doing before now, we are assuming independent groups. But if you look at one of what we've done before, there is one that we call a pair t-test, right? A pair t-test is, I'm having two groups, but they depend. But what if in a situation where I got more than two groups? That depends. I'm going to say that again. When we have two groups that actually depend, okay, we use a paired t-test. What if in a situation where we got two groups, or where we got more than two groups, and they depend? Of course, we cannot use sample t-test. We cannot use analysis of variance test, because the analysis, one of the assumptions of the analysis of variance is independent of the groups. And I want to tell you now, situation where we actually want to compare more than two groups and they depend, then we are talking about repeated ANOVA method, which is today's topic. You can say the story now. Statistical story is like a movie. You shouldn't miss out. Just like you go to a cinema to watch a movie, maybe along the lines you had a call. By the time you come back to the movie, you may not be able to understand the movie anymore. If it's a good movie, you may not be able to predict because you've already, lost some scenes. So that is the way statistical stories are arranged. They are arranged in a way they are connected. Now, like what I'm presenting today, I got more than two dependent groups. I can no longer use a pair t-test, and I'm actually going to use ANOVA with a repeated measures. Does that make sense? So which means what we want to do today is a generalization of a pair t-test. The pair t-test is only be used when the groups are, you got only two groups that are depending, but we have more than that. Basically going to use this guy. And that was why if you take a look at, it means the data we're going to be using is going to be a longitudinal one. What do I mean by that? Okay, it means I'm actually going to be collecting data from the same subject at different occasions. I'm going to say that again. I'm going to be collecting data from the same subject at different occasions. The occasion is going to be more than two. If the occasion is just two, of course, I'm actually going to go with a PRT test. If the occasion is more than two, I'm actually going to go with this topic. So the longitudinal data, that is what it means. So that's why you see, individuals, experimental unit, etc., they are being measured multiple times. Okay? That is why we call it ANOVA with a repeated measures. Okay? And this actually, it allows us to investigate the treatment effect on the response over time. We basically want to see, some people used to say,